In this video, I'll explain the null hypothesis in a very explicit step-by-step way and show exactly how we decide to reject or fail to reject it. First, we always write two competing statements. The null hypothesis, H0, is the default or status quo statement. The alternative hypothesis, H1, is the claim we are looking for evidence to support. Let's use the correlation example from problem 41. Now here is the core logic. We start by assuming the null hypothesis is true. Then we collect data, compute a test statistic and a p-value, and compare that p-value to alpha. That comparison tells us whether to reject or fail, to reject the null hypothesis. The p-value is the probability of getting results like ours, or more extreme, if the null hypothesis were actually true. A small p-value means the data would be very unlikely if H0 were true. Here is the decision rule. If the p-value is less than or equal to alpha, we reject H0. If the p-value is greater than alpha, we fail to reject H0. Now, let's apply this to problem 41. The p-value was essentially 0, and alpha was 0.05. Since the p-value is smaller than alpha, we reject H0. That tells us there is a significant linear correlation, so the regression line is safe to use for prediction. So the null hypothesis is your starting assumption. You only reject it when the data make it very unlikely. If the data are not extreme enough, you fail to reject it. That is the core idea.